What if humans could create a miniature sun here on Earth? A source of energy so powerful that it could provide nearly unlimited electricity. No fossil fuels. No pollution. Just clean energy created by the same process that powers the stars. It may sound like science fiction, but scientists in China are working on exactly that inside a high-tech laboratory. Researchers built a machine designed to recreate the nuclear fusion process that happens inside the sun. This project is sometimes called an artificial sundae. Its real name is the Experimental Advanced Superconducting Takomat. The goal is simple but incredibly ambitious. To unlock a nearly limitless source of energy for the future. But how does this artificial sun actually work? Why is nuclear fusion so difficult to achieve? And could this technology one day power the entire planet? In this video, we'll explore 5 fascinating facts about China's artificial sun and why scientists around the world are watching it closely. Number 5. What is China's artificial sun reactor? China's artificial sun is a nuclear fusion research reactor designed to study how fusion energy could be produced on Earth. Unlike nuclear fission reactors used in most nuclear power plants, fusion attempts to combine atomic nuclei to release energy. This is the same process that powers stars like our sun. Inside the reactor, extremely hot plasma is confined using powerful magnetic fields. Temperatures inside the machine can reach tens of millions of degrees. These extreme conditions allow scientists to study how fusion reactions behave and how they might be controlled for future power generation. Number 4. Why scientists want fusion energy? Fusion energy is considered one of the most promising future energy sources. The fuel used for fusion reactions can be derived from materials found in seawater. If controlled successfully, fusion could generate enormous amounts of electricity with very low environmental impact. Unlike fossil fuels, fusion reactions do not produce carbon emissions, and unlike traditional nuclear reactors, fusion does not rely on the same type of long-lasting radioactive fuel. Because of these advantages, scientists around the world are investing heavily in fusion research. Number 3. Inside the technology of a fusion reactor. Fusion reactors are incredibly complex machines. Inside the reactor chamber, gas is heated until it becomes plasma, a superheated state of matter. Powerful magnetic fields are then used to contain this plasma without touching the reactor walls. The goal is to keep the plasma stable long enough for fusion reactions to occur. Achieving these conditions requires extremely advanced technology, including superconducting magnets and sophisticated cooling systems. These systems allow researchers to study fusion behavior under controlled conditions. Number 2. The challenges of building an artificial sun. Although fusion energy holds enormous promise, it is also one of the most difficult scientific challenges. Temperatures inside fusion reactors must reach levels far hotter than the surface of the sun. Maintaining stable plasma under such extreme conditions is extremely complex. Scientists must also develop materials that can withstand intense heat and radiation. Because of these challenges, fusion research is still ongoing in laboratories around the world. However, each new experiment provides valuable data that brings researchers closer to practical fusion. Power. Number 1. Could artificial suns power the future? If fusion energy becomes practical, it could transform the global energy system. Fusion reactors could produce large amounts of electricity using relatively small amounts of fuel. Because fusion reactions release enormous energy, a single power plant could potentially supply electricity to large regions. Many countries are now collaborating on international fusion projects to advance this technology. China's artificial sun experiments are part of this global effort to unlock a new source of clean energy. Although challenges remain, fusion research continues to push the boundaries of science and engineering. Human civilization has always depended on energy, from fire and coal to oil and renewable sources. Each new energy technology has transformed society. Fusion energy represents one of the most ambitious attempts yet to harness the power of nature by recreating the same reactions that power the sun. Scientists hope to unlock an almost limitless source of clean energy. China's artificial sun experiments are just one step in this long scientific journey. Whether fusion power becomes a reality in the coming decades remains uncertain. But one thing is clear. The quest to build an artificial sun is one of the most fascinating scientific challenges of our time.